Okay, in 4.6, we're going to look at fermentation. So fermentation is going to allow glycolysis to continue making ATP when oxygen is unavailable. This is well, I'll demonstrate it in class with you guys, but you do a lot of things where you'll start to feel a burn in your muscles. That burn is fermentation. You are still breathing at that point in time. You haven't been like, oh, nope, I'm not going to breathe. You're still getting oxygen, but you're not getting enough to continue the process that you're wanting to do. So fermentation is an anaerobic process. It occurs when oxygen is not available for cellular respiration. Or it's also going to be done before you really start to get into the aerobic process. So it does not produce ATP. It allows for glycolysis to continue is what it does. So fermentation, again, you can see down here, if there's oxygen present, it's going to go to respiration. If there is none, it's going to go to fermentation. So fermentation allows glycolysis to continue making oxygen again when it's not present. What it will do is it will free up the electron carrier. That NADP plus is going to be recycled back to glycolysis. It'll be able to keep going. So during that process, when it does this, lactic acid fermentation is going to be what happens in most animals. Most people, most things are going to do lactic acid fermentation. And once the glycolysis has split the glucose into the two pyruvate molecules, the pyruvate and the NADH enter fermentation if they don't go into respiration. So the energy from the NADH converts the pyruvate into lactic acid, and the NADH is changed back to NAD+, so it can continue on and make energy with it. So fermentation, there's two different types. You've got alcoholic fermentation, and it's similar to lactic acid fermentation except for it doesn't make lactic acid. It's going to make alcohol and carbon dioxide along with freeing up those electron carriers. So in glycolysis, the glucose molecules and the products enter fermentation. Again, that NADH is used to split the pyruvate into alcohol and carbon dioxide. This process is going to be used in like baking breads and creating alcohol. So the NADH in that process is going to be changed back into the NAD+, and that NAD+ is going to be able to go back and continue the process of glycolysis. Something to keep in mind, I'll go on to the next slide here. It says that we use it in food production, but in our bodies, we store probably about 15 to 20 seconds worth of ATP in our cells. So we're going to be able to use that ATP first. And then there's a little bit of short-term storage within the cell, which can get us to about 30 seconds to 45 seconds. After that point, you're going to end up going into lactic acid fermentation, and you're going to do fermentation to about like 90 seconds. And then after the 90 seconds, that's going to be when you go into aerobic. You're going to go into the respiration process. So that's, again, something to keep in mind when you are like, oh, I want to lose weight or do things like that. Short spurts of exercise probably are not going to allow you to lose weight. Like I'd mentioned earlier, one of the best ways is you're going to end up needing to go anywhere from 20 to 30 minutes of a cardiovascular type of exercise, an aerobic exercise, to start burning lipids. If you don't do that, you're not going to burn the lipids, and you're not going to really see a change, a loss in weight. So that is something to keep in mind. So some food products that are created from fermentation are yogurt, cheese, bread. So those are some that are created during that process. So that is the end of the notes for chapter 4.